All right, video number 4, I think. Um, Stopping distance. Very simple topic if you get it. So, stopping distance is equal to thinking distance plus braking distance. Now, the best way to think about this, you have to visualize it. You're in a car right now, right? And you have your foot on the gas pedal. And you're just driving down a very dark road. Imagine a random cow jumps out from nowhere. You see, the first thing is your eyes notice the cow. The second thing is your brain or signals go to your brain and then back for you to press what? The brake. Any sane human will press the brake, yeah? So what we do is that's called your reaction time. So the time between seeing the cow and applying the brakes is your reaction time. The distance that you've traveled while you're reacting is your thinking distance, right? They could have called it reacting distance, but oh well, they call it thinking distance. So there it is, yeah? So distance traveled while reacting to a hazard. So it's the distance you travel between seeing the cow and touching the brakes. So the better reaction time, the less distance you will travel before applying the brakes because you're really quick and you can press it very quickly. So that's your thinking distance. Your braking distance is everything after you press the brakes. So you've pressed the brakes, depending on how good and how new your car is and your brake conditions, you'll take some time to stop because obviously brakes don't stop you within like 0 seconds, do they? They take a while, right? So there you go. So what we want to think about is the factors which affect your thinking distance and the factors which affect your braking distance. Logically, thinking, obviously cars do not think, so it's to do with the driver. So thinking distance is based on your reaction time. Your reaction time is based on these. So you got tiredness, drunk. Obviously, if you're drunk, you have a much longer reaction time. Is not good because you take ages to stop. And drugs, some make you react faster, some make you react slower. Won't give any specific names, you don't need them. Visibility of the road, if it's foggy, you're probably most likely going to collide with a cow. Speed of the car as well. If you're moving faster, the distance you travel is obviously more. So speed of the car. Also, distractions, be it a mobile phone or talking to someone. Yeah. So those are all to do with the driver. With the exception of this is for both. But speed of the car is probably the one you have to know that applies to both. Now, for braking distance, it's to do with the car. So if I just have some prompts for you guys, thinking distance to the driver, braking distance is to do with, yeah, it looks like a 1972 car, but whatever. So braking distance to the car's mass, the brake conditions. If you buy a brand new car with brand new brakes, you find that braking is very smooth and very quick. If you have a rusty car from like 2000 BC, it takes a heck of a long time to stop. Tire conditions, you need very good tires. They need good grip to stop very quickly due to good friction. Road surface, obviously if it's a wet road, you take longer. If it's a sandy, rocky road, you stop way quicker. Speed of the car as well, yeah? So there you go. So you need to know these guys for the exam. At least try to get, 4 or 5 of each. So let's now look at this. This is where things get interesting. Same car, just different speeds. Same cow, same distance, yeah? So what we're trying to say is, imagine that you want to stop at this point here just before you hit the cow because you're such a rebel, right? So you like living life on the edge. You want to stop just exactly at that position. Which scenario, A or B, will you have to apply a greater braking force to stop there? Obviously, you'll have to apply a greater force here, right? You're traveling faster. For you to stop within the same distance as there, you'll need to apply double the force for you to stop there, correct? So what we need to understand is the greater you're traveling at, the greater the speed you're traveling at, the larger braking force needed. Which is why, folks, obviously if you go 120 miles per hour and suddenly you need to stop there and then, you will have to apply a massive force. And that massive force, remember guys, Newton's third law for every action is equal, opposite reaction will be applied on the driver themselves, which is why sometimes the driver, so you're driving, you're like, let me pretend this is a car. So you're going vroom, you're driving like this. Suddenly you stop, they have to stop, you stop straight away. Because you stop so suddenly, you in the driver's seat are going to go flying out of the windscreen and probably headbutt the cow or something because you just have way too much braking force. So what we need to understand is braking force is kind of related to the amount of risk. The harsher you have to brake, the more risk there is to the driver, and there is risk of what, like stuff like whiplash. Believe it or not, people flying out of the windscreen, which is why we wear seatbelts to absorb a lot of the excess energy for us to avoid, flying all over the place. Yeah. So once again, we're linking speed to braking force. So the greater the speed, the greater the braking force you need to stop. And if you have a greater braking force, you need a greater deceleration, which means, that you're most likely going to injure yourself pretty badly, usually whiplash, yeah? Or you just go flying somewhere. So this is pretty much what you have to know. Once again, this formula, you have to know this inside out. These, try to memorize them or just understand them. It's quite logical. This is logic. You don't need to memorize. And let's now go to this 6 marker. They love giving you this. Yeah, they give you this graph. They say identify the trends. And you're thinking, what am I meant to do? Now, if you understand the previous 2 pages, this should be easy. Stopping distance, without even looking at numbers on the graph, is always equal to what? This plus this, right? So stopping distance is braking distance plus thinking distance. You write that as your answer, you already get 1 mark. Yeah, you might think, nah, you can't get marks for that. You can. Because if you actually to verify it on the graph, I guarantee it'll be true. So let's say there the braking distance was like 20, and then the thinking distance here was like 10. On that same area there, this would be 30. So like when you add these two, it always gives you that. Yeah. So stopping distance is braking plus thinking. Also, what we mention is you give factors which affect each. So what you can say is, as the speed increases, that affects both your thinking and braking distance, which we've written down here. Speed of the car affects both of them. Yeah, you get another mark for that. You're thinking, yeah, that's a bit obvious, but you go to the second mark. Third, fourth, fifth mark, you can talk about the factors which affect both of them. So thinking distance affected by driver's conditions, and you can expand on that. Braking distance depends on the car conditions and the road conditions. And what you can mention is the larger your stopping distance, the more dangerous it is for the driver. You got your full marks. Done. If they say analyze trends, I always suggest just using a few numbers just for the hell of it. So what you can maybe say is that when your speed is maybe 40 miles per hour, or 40 meters per second, your thinking distance is X or whatever number, your braking distance, whatever number, add them to get stopping distance, maybe compare it with half the speed. And what you notice that, like, you'll obviously get a different numbers. But you just put numbers just for the sake of it, yeah? And you get marks for that. So that's pretty much this entire topic done.